Well, hey, cool, thank you. So it's lovely to get to talk to you all today. As you may have guessed, I'm a massive fan of R, and I'm basically going to teach you about how R has helped my practice as a clinical scientist, and yes, hopefully convince you why R is a clinical scientist's best friend. But first, I'm a clinical scientist. Many people don't know what that is. So I'm a registered healthcare professional. I work full-time in the NHS. I'm not an academic or a research scientist. My job is all about serving NHS patients by providing lab testing. So I specialize in the genetic testing of cancer. And to talk and put a bit more context to this, it's always best to start with a patient. So this is a little girl called Alice. Alice is a real patient. If you want to read her story, I've put the URL down there. And Alice is not a patient that I had any contact with during her care, but her story illustrates the point I'm trying to make. So when she was 1 year old, she got diagnosed with a type of nerve cancer called a neuroblastoma. And essentially, when someone gets diagnosed with a cancer, if you do genetic testing on that cancer, it can shape the treatment that they receive. So what would happen is that you take a sample of the cancer, usually through surgery or a biopsy, and that will get sent to a lab where I work. So I work in the Manchester Genetics Laboratory. And at the Genetics Laboratory, we will do genetic testing, which is a long series of cool chemical reactions and lots of different machines. But ultimately, it produces a huge amount of data about the genetic makeup of that cancer. And that data will be run through an analytical pipeline. This will be built and curated by people called bioinformaticians. So they are also accredited healthcare scientists, but I am not a bioinformatician. Bioinformaticians have formal training in how to code and do software development. I come in the next stage, which is that the outputs of that analytical pipeline get manually reviewed by clinical scientists like me. One by one, we look at the outputs, look at it in context with the patient's clinical presentation, and then we will manually write up a result, and that gets sent back to the doctor. The doctor then uses that to decide what the best options for treatment are for that patient. So in Alice's case, her cancer had a particular genetic change called a MYC-N amplification, and that means it's quite high-risk cancer. So as a result, they gave high-dose chemotherapy, and according to the website, thankfully, the tumor went into remission and she got better. So that's the whole point of this, is that genetic testing enables better treatment options for patients. But then in December of last year, I got given a task, and the task was, okay, we want to make a new genetic test for cancer. And that means developing a new altered version of this whole pathway, going from the sample all the way back to the result and back to the doctor. So it's worth putting into context that when a clinical scientist like me is normally given this kind of task, we would normally go to Microsoft Excel. Microsoft Excel is the only thing that I was ever exposed to during my training, and it's ubiquitous in NHS genetics labs. But I've been dabbling with R for a number of years, and I thought, okay, I really want to try and use R more in these kinds of projects. And I thought, if I'm going to do this, there's basically 3 steps to this project. Step 1 is to assess. I want to assess if this new genetic test pathway that we've done is good enough. Step 2 is to document it. So we have to show that it's good enough. So we are an accredited lab. We're accredited to international guidelines, which basically states that you can't just offer a genetic test and say it's good enough. You have to be able to prove that with objective evidence. And finally, if you've made a test and you start offering it to NHS patients, you then want to monitor it and check that it remains good enough as it's gone live, effectively. So I thought, okay, I made a GitHub repo, which is public. Please take a look at it. Let me know what you think. It's got a very uncatchy name of pan-solid CNV validation, which is just the type of genetic test we're working on. If you're really interested, I can talk about what that means. But anyway, so the first step was I needed to assess this new genetic testing pathway. And I realized, okay, I need to collate lots of data together. There will be lots of different data formats from different points in that process. And the first one was genetic results from the analysis pipelines. This was a new analysis pipeline that had been built by a colleague of mine called Lizzie Sollers. And the results came out in Excel format. And as a clinical scientist, normally what I do would be open Excel one by one, have a look at this patient, open Excel, have a look at another patient. But I realized I could read Excel to make a function that would operate over all of these Excels. So there's 120-ish samples that we tested. Each Excel has multiple tabs. Each tab has multiple tables. Collate them all together, and it's a few thousand rows of data. I then wanted to add on information that we had stored in our lab database, which is written in SQL. So this would be information like the type of cancer that the patient had from the referral form, and also which machine in our lab was the data generated from. So using an ODBC connection and dbplyr, I could query the database, extract the information I wanted about those samples, and pull it together. And the final sort of data type was information from other test results that the same sample had. And these came in a variety of formats, mainly HTML. So you get these very long HTML files where somewhere down in the middle of it was a table that I was really interested in. But using the RVEST package, again, I could write a function, pluck out specifically that table from all of these different files and collate them together. And the reason I really like this is because I don't write SQL, I don't write HTML, I'm very much a beginner, but these R packages like dbplyr and RVEST are such a great toolbox that allow me to just get on and do stuff without having to learn an entirely new language. So once I've brought it all together, I use tidyverse packages, mainly ggplot2 and dplyr, to do some exploratory data analysis on this new test. So as an example of the kind of stuff I was doing, this is looking at the new test detecting gene changes across different cancer types. So the x-axis is the genes we're looking at. Genes are always these capital letter alphanumeric codes. And then on the y-axis is the dosage, so the number of copies of that gene. And those x and y-axes are taken from the output of the pipeline, so there's Excel files. But then I used facet wrap to add on information from the SQL database, which is about which type of cancer it is. And if you look, each one of those dots represents a sample that we tested and a result. And you can see that, for example, brain cancers have a different genetic profile to colorectal cancers. And that's what you'd expect. That's what you read in the literature about how these different types of cancer evolve as they're basically developing in a patient. And the genes that we were interested in, just as a background, these are all genes that basically code for instructions to tell cells to grow more. And if you then have increased number of copies, increased dosage of that instruction, you get repetition. So you get grow more, grow more, grow more, grow more. And that's one of the ways that cells can basically grow as cancer cells. And Alice, the patient I mentioned on the first slide, her gene was a gene called MIC-N, you can see there. So that's not her data, but that's the type of cancer change that we were detecting. So this looked really good. Our new test can detect different gene changes, different cancer types. We could also look at the correlation of our new test with a different test. So the way I describe this is, imagine you have a ruler and you want to know is your ruler measuring correctly. And one way to do that is to take your ruler, measure an object, and then you take a different ruler, measure the same object, and see if the results line up. And this is basically all I do in my job, is I take samples, measure them with a new genetic test, and then measure them with a different existing genetic test to see what the correlation is. And this plot basically shows that the new test on the y-axis had a good correlation with an existing genetic test that we already had. And we were able to show that that is kept true both at low dosage levels and at high dosage levels. So this was looking really good. And we thought, okay, the test is ready to go into clinical service. And at this point, I want to point out that I'm accredited with this organization, the Health and Care Professions Council, and they have a list of standards that clinical scientists have to meet, one of which is that a clinical scientist should gather appropriate information, analyze, and critically evaluate the information collected. Now, for me, I think tidyverse is just brilliant for this. It's changed my practice. I'm going to use it a lot going forward because it makes everything just so much easier. So to go back to the tripartite structure, I had to assess that this test was good enough, sensitive enough, accurate enough. Done that, but then the next stage was to document everything that I'd done. And it's worth pointing out, my lab has a very specific document format. Documents have to be in Microsoft Word, it has to be Palatino linotype font, and it has to be type size 10. And there's a bunch of other formatting as well. And that's not just someone being pedantic, like we have to produce documents in a consistent way because it's part of our accreditation. And originally my way around this was, okay, I'll just have this long R script that I'm making these plots, and I'll use ggSave to get the plot out of R, and then I'll manually copy and paste that plot into a Word document that I'm typing out. And that worked okay for a bit, but then as things started to get longer, I got more and more plots, and I started to forget which plot goes where, and if I've updated the script here, that means I need to update the Word document, but I can't remember if I've done that or not. And it was really, really painful. And I was reminded of this scene from The Simpsons, where Homer makes orange juice by grinding an orange into his eyeball and getting orange juice that way. And I thought, maybe I'm Homer. Maybe I found a very painful way to do something that shouldn't be this painful. And maybe, like Homer, I'm going to go, you mean there's a better way? And I actually came to this conference last year, and I remember one of the speakers just put up a slide that just said, do you know Quarto? And I can remember my first response to it was, who's Quarto? I genuinely thought Quarto was a person. But as soon as I'd worked out that Quarto is not a person, I thought, oh, I can use Quarto to solve this problem. So I started out with a template document. It's just a Word document, formatted, as you see, Palatino linotype, exactly as my lab requires, made sure all the formatting was correct in Word, and then have an analysis Quarto markdown document which has R code chunks showing all of the different analyses that I've done on this genetic test. And in the header, to the reference doc field, I will add my template. And then when I hit render, this beautifully formatted report gets automatically generated, and I don't have to do anything in Microsoft Word. So the first time I did this, I was so happy. I just double punched the air, and I was like, showed my boss, and they were like, it looks exactly the same. And I was like, that's the point. That's the point. Anyway, I mean, the thing that I love about this is that it both meets the requirements of my lab and that formatting structure, but it's also very transparent. So when I get asked about a particular threshold we set or a calculation we did, the calculations are there within the document, effectively, which makes it really, really useful if you're validating a genetic test to go live and to keep using it. So again, just to drive home the point, the HCPC say that clinical scientists should communicate the outcome of problem-solving and research and development activities. I think Quarto is a game changer for this because synthesizing the analysis and the communication of results when you're making lab tests is so useful because it cuts down and simplifies a process which is otherwise quite messy and quite difficult to come back to and understand what was done. So I'd assessed whether the test was good enough, I documented it to show that it was good enough, and we then brought this test into clinical service. This went live in April of this year. So the next stage was to monitor and check that it was remaining good enough. At this point, I want to introduce the winning board. This is a whiteboard that my boss added in our office, and we thought we could write on things that we'd done well, and it was a nice morale boost. So over in the bottom corner, you can see I just started writing up the numbers of samples that had come through the lab for the tests that I'd worked on. I was just doing this on a week-by-week basis. We'd just scrub it out, write on the numbers again, just to see what kind of impact I was having. And yes, you can see there's a little image there of a guy doing that. That's my boss's drawing of me. When I did something good in R, they were like, okay, I'm just going to draw a picture of you now. But I realized I wanted a more formal way of getting the numbers for the samples that had been tested. I thought, oh, okay, I can make a Shiny app. I've heard a lot about Shiny. I'd really like to have a go. So I started off by making this plot. I wanted to track the quality of batches going through the lab. So on the x-axis, I wanted the batch. We processed these cancer samples in batches of 48. And then on the y-axis, I wanted this quality metric. We had this quality metric that basically goes from 0 up to about 3. Lower is better, so the closer you are to 0, the better the quality of the data. As soon as the quality gets above 1, then you have to fail the sample because it's just not good enough to call. So I plugged this in, got this plot out, and I thought, okay, this looks good. I can see the batches are going along there. The majority of samples is quite close to 0, which is good. You don't get too many samples going above 1, so we're not having to fail much. And the quality seems fairly consistent. Except then I noticed there's this step. All of a sudden, after one batch, the quality across every subsequent batch got worse by a considerable margin. Not enough to make it fail, but enough to be concerning. So I went and talked to one of our technicians in the lab, And they said, as that batch changed, they used a different lot number of a reagent they were using in the lab, which I thought, okay, this is interesting, but it doesn't explain what happened. And at this point, my colleague, Lizzie Sollers, actually found the solution to this. She did some bioinformatic detective work, basically found that in all the subsequent batches, out of 11,000 genetic data points that we look at, 39 were just missing. They weren't there. And the missing data had increased the noise in the sample that we were measuring and it basically made everything look slightly worse quality. So then the question is, well, why was there suddenly data missing? The ultimate cause was a manufacturer error. The manufacturer admitted that in the new batch of reagent that they'd sent, basically they didn't include these critical chemicals to target all of the genetic points we were interested in. So they have now put in a quality control check to make sure that that doesn't happen again. We're putting checks on our end to make sure we can catch this sort of thing. And thankfully, no patient care was affected by this. The missing data was for genetic data points that we weren't reporting back out to the clinician. So it's a near miss, but it's one that I'm really glad we picked up on. And I think this speaks to the power of Shiny, the power of being able to customize the view into what you're really interested in. And I probably sound like a broken record, but yes, the HCPC say clinical science should recognize the value of gathering and using data for quality assurance and improvement programs. I definitely think Shiny is really good for this, and I think it has a lot of potential in monitoring tests and giving real-time feedback on how those tests are doing. So I'd come to the end of my sort of three-part structure. I'd assessed the test with Tidyverse, I'd documented it with Quarto, and I'd monitored it using Shiny, all without using Microsoft Excel. So this was basically a real win for me. But just to sort of wrap up, I'd like to finish by pointing out the HCPC also have this standard about a clinical scientist should identify the limits of their practice and when to seek advice. So I'm aware that I'm not an expert in R, and the work I do does affect real patients like Alice. So I'm very keen to learn from this community about how to best use these tools. And if you have any comments or suggestions on my code, please let me know. I'm really looking to basically get better at this. So I will finish up there. I'd just like to acknowledge a number of people. I work with a really great team, and this is all a great collaborative effort. Particular thanks to Elizabeth Sollers. She's the bioinformatician who's worked very closely with me on this. But also, I'd just like to say thank you to the NHSR community. I think you do great work. Particular shout-outs to Tom Smith from Nottingham, who gave me some great advice on this, and also Luke Shaw, who introduced me to R in the first place. So thank you very much, and happy to take any questions.
So we've got a couple of questions in the chat. First of all, how do you check that you're extracting the correct data or all the data you need from Excel and HTML? Do the structure of these inputs ever change?
Thankfully, from the Excels, the structure was consistent. This was one of the reasons that working with Lizzie was so good, was because she was controlling the output of the pipeline. So we could have these discussions about exactly what is going to be exported. Because it's a problem in genetics is often the problem is just filtering. You know, the human genome has 28,000 genes, and I was interested in 9. So yes, it's all about controlling the output of these pipelines. And the same with the HTML. There was a lot of filtering that had to be done. But again, if you're confident in what you're interested in, then that's a lot easier. So if you're saying out of 28,000 genes, we're interested in 9, that makes it more manageable.
That makes sense. Are colleagues seeing the use of R as a benefit? Are they on board, and are they looking to learn as well?
I'm trying to convert them. I've given a few demos to them of R and kind of tried to show them in real life use cases. I think one of the things that maybe holds people back, maybe holds clinical scientists back from using R, is that a lot of the stuff that's on the internet maybe feels not quite in our domain. And I've tried to show them use cases of saying, okay, let's imagine you want to solve a problem like, you know, the DNA extractor might not be working correctly and you want to work it out, you know, cross-referencing against the lab database. I've tried to show that. And I think people are receptive when they can see the sort of efficiency gains. And also, I think it really comes into its own when you're offering a test live, and you have to go back and correct and see the analysis that you've done in a new light. I think that really helps. So yes, it's a work in progress.
And I suppose as a follow-up question, how can we as a community support the sort of adoption of R or Python, Quarto, all of these tools for clinical science?
I think, I mean, to be honest, I think you're doing an amazing job as it is. I think kind of popularizing it, I think the Coffee and Code is a really good way in, because it's a sort of low stakes way for people to just sort of pick up things. And I think, yes, it's a lot about many things that have gone on in this conference, sort of shouting about what you've done well, but also being honest about, oh yes, and this didn't work first time. I think there's a perception, certainly, you know, when I started out, I didn't know how to code. There's a perception that people who can code are just sort of they're not quite human. They're just this other, you know, completely unattainable level of understanding. And actually, I think it's about breaking that down and saying there are many, many steps on this sort of road to being a master. And if you only take a few, that's fine. That's a lot better than just staying within the current work patterns.
So we've got a few other questions in the Slack, maybe that you can take a look at after. Also, sure. Plenty of Excel horror stories for everyone to enjoy.
Lovely, always love those.
Then that's probably we keep things on track.
Sure.
Please clap. I'm glad a few people got that reference. So next up, we've got Laura Birks. Okay. And Laura is talking about the use of Shiny to automate routine reporting.
Get my steps in. Hello. Yes, my name's Laura. My pronouns are she and her. If you want to talk about me behind my back or about the talk with your friends. It's an intrinsic part of who I am that I apologise at the start. So I made these slides on a Friday, and I think it's quite obvious that I did so. But I've seen some GIFs already, so I'm feeling all right. I'm feeling a bit better. So I work in the southeast region of NHS England. I work in the data and analytics team, and I cover ops, flow, and health inequalities. So under flow are things like acute and community discharge, and under acute discharge, we find a very manual discharge report that we were running as a team. So in short, the process is probably familiar to a lot of you that work in reporting, but we would extract data using SQL. We would manually copy it into an Excel report. We would hit at least one refresh button. We would change some filters, and then we'd copy manually our outputs into slides, and we would write some narrative to go with it. And then our favourite bit is that we would then go and ask someone to QA the whole thing for us. So this was, we acknowledged that this was kind of already a vastly inefficient process, but it was kind of what we had. So we were trying to think of ways that we could kind of reimagine this report. So we had three main goals. So the first was to completely automate the whole process. So that was kind of a selfish analytics goal. Secondly, we wanted to produce a better report for stakeholders. So we didn't just want to automate what we had. We wanted to make it slightly better, better analytically, but better visually for our stakeholders. And then finally, for everyone, we wanted a kind of more consistent and less prone to error process. So part one of the piece of work, and what we actually thought at the time was the only part of the piece of work, was the automation of the pack, which the process I've summarized in 2 GIFs. So we wanted to use the kind of skills that we'd learned from NHSR conferences, hacker conferences, to wrap the process, but at the same time we had to recognize that NHS England can't quite get rid of PowerPoint, and this is one of my stakeholders. And it's kind of understandable. People want to be able to kind of like steal slides, put them in other packs. They want to be able to go in and write their own narrative where it's relevant for their program. So we didn't want to completely prize their beloved PowerPoint from them. So we needed to find workarounds that enabled us to feel like rap gods whilst also creating output in PowerPoint. And thankfully, the Officer package exists. I know it's been referenced a few times, but it's really helpful for kind of getting a PowerPoint template that our stakeholders know and love and kind of outputting our analytics into it. So we have our new pack, and as Joe just said, it's great when stakeholders can't really tell the difference between the old and the new process. So it looks very similar. We have significantly truncated the process and the QA kind of burden on that. And we've gained a lot of benefits from doing that. And I won't go through all of them, but basically they're all RAP things that we know that RAP's good for. So we're kind of getting that automation, the consistency. We're reducing the failure and error risk. And we're kind of lessening the burden on ourselves. But for us as analysts, it kind of all boiled down to a massive saving in time. We've saved ourselves, I think, a couple of days of analytical time a week just from going from a completely manual process to an automated one. So that's it. We're done. We can all go home. We've got what we want. Obviously not. So using this extra time, we sort of started to ask ourselves quite scary questions, like why? Why have we done this? We've freed up a load of time, but actually, what are we going to use this time for? And how are we actually adding value to this automated report? We know we don't want to just go in and click a button. That's not who we are as analysts. It's not what we want to bring to the party. So we're asking ourselves, how are we adding value as analysts? And I think we knew pretty clearly what we didn't want to be. So we didn't want to be a kind of a data service that kind of just regurgitated stuff for our stakeholders. And we didn't want to create reports and then just send them off to live their own lives out in the system. So we were trying to distill what it is that analysts are good at and what analysts do. So in the simplest terms, we're really good at translating data into insight, so trying to turn masses of information into intelligence. We think we have special skills in telling stories with that intelligence, so telling people what to look at and potentially what not to look at, and also leading discussions with stakeholders. We really want it to be an intelligence service where we say, you don't need to worry about that. You think you do, but you don't. This is normal. What you really need to worry about is this other thing that's going on over here. So that's what we wanted, and we kind of distilled that down, as I said, into kind of writing insightful narrative to go with that pack. So we decided that we'd saved all this time automating the pack, but what we actually wanted to do with that pack, or with that time, was feed it back into the pack and basically just create narrative and discussion around that. So that brings us to part 2, which I've called unautomation. So what did we actually need? So we needed something that was statistically sensible, statistically robust. We didn't want to be doing point-on-point comparisons, and we didn't want to be doing SPCs where all the settings are the same for everyone and every metric, because we felt like those were bringing out the wrong or potentially missing things or bringing out false positives. We wanted to be comprehensive in the metrics that we looked at. So we'd kind of negotiated with stakeholders earlier. We said, if you let us just report a few metrics routinely, we promise you we'll look at absolutely everything else in the background that could possibly be going on. So we also wanted something that could kind of cover that comprehensiveness with our metrics. And we didn't want to go back to where we were before, so we wanted to do something that was efficient. So we created a shiny dashboard. It's analytics facing, so I will warn you now, it's pretty ugly. We wanted something that would basically, as I said, reduce those false flags, but uncover ones that potentially we would have missed if we'd batch applied settings, and we want to iterate over all of those measures, all of the geographies, and multiple time periods. So as I said, shiny dashboard, excellent. So if this was the process before, we had helper files that fed into a main kind of running file, which took as an input a PowerPoint template and then output our files. Shiny allowed us to speak the same language, so we built on the NHSR plot the dots function to kind of add to it and take all the inputs and output basically the same thing, but that looked exactly the way we wanted it to. And then we just needed a script, a server, and a UI that wrapped that all up. So I didn't think I'd be able to do a live demo. So I've done a video, but now I'm realizing that I don't actually know how to press play on the video. So if I look pathetically over there, maybe someone will click the button. Thank you. Anyway, so we can see we've got 15 months of data. It's a basic SPC. Is it going? So anyway, so you can choose system, provider, or regional level. You can choose which metric you want to look at. You can choose how many historical months you want to look at. And then within those months, once you've filtered down to the dates that you're interested in, you can choose your process change date at that point rather than applying it to everything, and you can choose which direction the improvement's in. So if we said in the slides, potentially, no criteria to reside, occupancy is increasing at this provider, we could go into the provider, click through all the settings, and there was a really nice example of when a chart would have come up with a statistically significant result, so it would have said, oh, performance is getting worse against weekend and weekday daily discharges, but actually we know that that's down to a change in the sitrep reporting. So we're able to basically say that flag's a false flag. We could then write in the narrative either that there's nothing to worry about there, or vice versa. If it was the opposite way around and it wasn't flagging but then became flagging, we could say something that we would otherwise have missed. So I'll just move on and assume it's not going to happen. Cool. So what have we gained from the two parts of our process? From the first part, we've now got a fully automated pipeline. It's completely based in R. We're outputting to slides, and we've got kind of less error and an efficient approach. And we freed up that time to use on exception reporting. So we're trying to identify true changes in the data and ignore anything that kind of erroneously would have come up if we hadn't been able to like click around with the dashboard in the background. And we think it's a nice balance of kind of, we do like dashboards as analysts, but they don't always need to be stakeholder facing. We can use them as tools that kind of help us to do our job without sharing them with stakeholders. So bestgrades.co.uk told me to always finish with some take-home messages. So here they are. We should be adding something to the data. We shouldn't just be kind of churning and giving it back. Our special skills, if you want to call them that, are turning data into insight, doing that storytelling bit, driving intelligent conversations, and basically helping stakeholders know where to look and what questions they need to be asking. And I think something that I've learned, particularly from this piece of work, and I'm trying to bring into all my interactions with stakeholders, is that we need to be unafraid to like write narrative like this, where we basically say, here are the numbers, but, you know, there's nothing to see here. It hasn't changed since the last time we spoke about it. There's no statistical change, but at least, you know, automatically I've output the numbers. But I'm not wasting time writing paragraphs that basically say nothing is happening. And I think that's it. Thank you.
So it looks like we've got a couple of questions coming in. To start with, have you considered measuring the kind of monetary value of the time that you've managed to save by doing this? Likely to be quite a large number.
Yeah, I think it was like such a big saving that it would be more time to monitor it than... So we now only spend maybe a couple of hours a week on this report, where before we were spending a couple of days, including like QAing every step of the process. So as an approximate, that's what we've what we've managed to save.
The number's so big that there isn't a word.
Yeah, exactly.
Just go with that.
That's an analytical technique, right?
Do you add your narrative within R or at the final stage in the PowerPoint?
No, we add it at the final stage. So the automatic process basically spits out a PowerPoint pack that has no narrative in it and just has an empty box. And then the benefit of that is that colleagues that maybe don't have access to the same data as us can run back the Shiny app and kind of add narrative as well. So we can kind of also crowdsource some of that stuff as well. So yeah, the narrative is added afterwards.
So we've just had a bunch of questions pop up just now, so we'll cover a couple of them, but you can look at those afterwards. Does the time freed include some time to do code maintenance and development? How much time do you put aside?
Yeah, so I put aside a little bit of time every week to keep an eye on it. There are always kind of requests for updates as well, so things like, can you change the colour on that because some other tool has changed the colour of what the Southeast region should be, so can we match it, that sort of thing. So there is time in my diary to kind of fix things, but yeah, it's compared to what we were doing, it's kind of much smaller.
And lastly, a question that I think is probably echoed by a few different people. I would love to see the code behind your pipeline and dashboard. Are you able to share/publish? Yeah,
so if you're in NHS England, it's on the GitHub. If you're not, then I'm happy to share the code. It's not got the data behind it, so I'm happy to share if you get in touch.
Brilliant.
Thank you.
So next up, we have Kenneth, who is talking through his process of self-development, web scraping, bank complaints data.
Cool. So thank you for listening. So in this talk, I'm going to explain how I gained experience in Python whilst maintaining my BAU work. And when I talk about experience, I mean technical knowledge, so knowing how to build, ways of working, knowing how to build well, and building capability. The thing that I'm building works and works consistently. So why am I doing this? In order to progress in my career, I need a range of skills, such as web scraping and Git. But how do I gain them whilst working on projects or platforms that cannot utilize this technology? And this is where the NHS provides continuous professional development, whereby I can identify and implement my professional development plans in the order to progress through the NHS bands and potentially earn more money. So, the scope. So, with that business justification, let's define my project. So, first of all, the skills that I want to learn. Web scraping in Python, version controlling in GitHub. The data will be complaints from the Financial Ombudsman Service, and the aim is to scrape bank complaints data and present them with a table with metadata. So first of all, why bank fraud? Fraud is the most common crime in the UK, and in the Justice Committee in Parliament, it clearly explains that this country does not have the infrastructure to deal with the scale, complexity, and evolving nature of fraud. And this is where the ombudsmen come in. If a bank refuses to refund a victim of fraud, they can take the complaint to the ombudsman, whereby the ombudsman publish for impartial adjudication, where the ombudsman publish the complaints openly on their website and provides a PDF detailing the complaints. So in this case, the PDF details, in this example, a victim of a scam where she lost around over $3,000. So with the data defined, let's look at the capabilities. The hardware, I will be using my corporate laptop. The software, I will be using Git, using my GitHub account. In terms of Python, I will use in Anaconda and writing my code in Spider. And in terms of time, it will be ad hoc, which averaged around 0.5 days per week. Now, in terms of the ways of working, I want to implement a vertical or thin slice approach, whereby I want to develop an end-to-end feature that is just enough for it to be usable and deliver value, i.e. a prototype. And what I want to do is a wrap approach, good version controlling, creating a new branch for a new feature, and then implementing a pull request, committing regularly with small pieces of work. And then there's the good coding practices. Well-documented code, storing parameters in a specific file, and adding all my libraries in a single file that requirements.txt. So what I'm going to do now is just to give you a rough view of the implementation of this project. So first of all, the thin slice. So as you can see, this is a crude description of my thin slice. getting the search data, scraping it, then scraping the complaints data, wrangling it, and just creating metadata and forming it into a usable table, my output. So, first step, getting the URL. So from the website, if you implement this kind of search suggestion, it will generate a URL. So from visual inspection, we can identify the parameters, the keywords, scam, and the date range of the complaints. Once you implement that URL, I can experiment with various Python libraries. So in this case, this is Beautiful Soup, whereby when you push the URL through the library, it generates a HTML file, as you can see here. And from visual inspection, you can link the metadata of the search entry, as you can see here, to the HTML, and thus you can scrape it. Next, once you click on the search entry, it will generate a PDF. So for a bit of experimentation, I'm using the PyPDF2 library so that when you feed in the URL of the PDF, it generates, it can pass through the text, and as you can see, here, it can generate text as a machine-readable string format. And thus, you get the final product. So this is a sample of a table whereby you got the metadata of the complaints. You also got a sample of the complaints which I try to wrangle, as well as key metadata from the PDF documents. For example, the scale of loss, which lists the magnitude of transactions lost to fraud. And as you can see, it's actually quite common. People lose tens of thousands of pounds of their own money through fraud. So finally, just a retrospective. What have I learned? The corporate machine tends to get an allergic reaction to Python. They don't work well together. So my solution is talk to IT to be specific of what's the minimum requirement. It's hard to balance good code writing with the progression of work. And the solution, plan, add the time in to allocate time to refactor code. And finally, it's hard to find a natural stopping point. I want to learn more about web scraping. I want to learn about natural language processing, but there needs to be a stopping point. And hence why I would suggest a solution of a strict acceptance criteria. Now, the cynical among you may be asking, why the hell am I wasting taxpayers' money on a vanity project that's not even related to healthcare? So first case study of the skills that I've learned. So first of all, open safety. It is a trusted research environment whereby I can send queries of primary care records from TPP. Now, open safety has certain restrictions. I can't see the data. I can only work with a test data. So this is my project in looking at descriptive statistics of ADHD pre and post COVID. In open safety, it works using an Urkel language. In order to do this, I need to store files in parameters. As you can see here, this is my parameter files through my bank scraping. This is the YAML file through open safety. So the knowledge that I'm learning through this project can be applied to open safety. The next one is that it needs to be worked on GitHub. So as you can see here on the left, this is my first ever pull request on GitHub. And thus, I would have to do the same thing again when I'm writing code on open safety, generating a feature branch and then sending a pull request into main. The other case study I want to show you is the federated data platform. So this is a piece of technology where it brings together data from different NHS organizations into a single platform. In order to deliver RAP, I must understand and test the RAP capabilities and functionalities of FTP. So knowing what I need to look for. So how do I clone a GitHub? So from previously, I have to clone a GitHub library. It's somewhat different in FTP. And by doing this, my project, I understand the capabilities required in a platform to deliver RAP. Likewise, so FTP requires a different way of installing libraries. It is, by doing this project, it has given me what to look out for in order to deliver good RAP. So in conclusion, I've been using my continuous professional development time to build a RAP process for web scraping. And by building the RAP, it has provided me with vision and instinct of what does good RAP looks like. And I can apply these learnings to bring these skills to into new projects and technologies. So I'm going to wrap it up there. So thank you. The code's available on this GitHub link, and I'm happy to answer any requests through this email. Thank you.
So, yeah, a couple questions in Slack. Will you be trying to do a new CPD project on an annual basis? Have you discussed with your organisation the value of formalising protected time for personal development?
So, on paper, we should have CPD time allocated, and thankfully, in the data science team, we do have a professional capabilities that look out that potentially that guards and try to utilize the CPT time as much as possible. So in terms of learning, I would recommend in an organization, in order to implement CPT time, just have a 15-minute discussion as a group. What do you want to get out of it? Is it actually practical? Is it actually practical? What kind of time can you slot it in a particular fixed point of the week? For example, a Friday afternoon, in order to implement, in order to secure the CPT time. So,
and as a follow-up to that, I suppose what's the next thing you want to learn?
I'm currently trying to learn how to use develop a website through. I think it's called not Selene. Basically, to generate a website where people can. Whereby people can enter information and that can scrape data and feed back the information. So instead of the financial ombudsman, it will be the Financial Conduct Authority in which I will be trying to scrape data. So yeah.
And do you think there has to be a BAU reason for learning, or is it okay to learn without a specific work-related project in mind?
Difficult question. We are paid. Oh, I mean, we are funded by the taxpayer. It's important to shoehorn a BAU reason for your project, and why that is useful, and what skills can that bring to you and the organisation. Yeah.
And I suppose lastly, I mean, again, there's a few on the Slack that you could come to, but when web scraping, how do you ensure you stay within the law?
Okay, so when I'm web scraping, this is open source data. I can simply manually download it one by one. There is nothing commercially sensitive. I am not trying to present it in a particular viewpoint. I just want to extract the key information from it. So I don't see how it's breaking the law in any way.
Yeah, that makes sense. I think. I think the rest of the questions best served for the Slack.
Cool.
Thanks very much.
Cheers.
And last of all, we have Matt talking about GitHub as a team sport.
So I'm just checking the time. It is after midday, which means drinking is okay. Everyone's brought some little snifter of something, haven't they? Is Rian in the room at all? Good, the drinking game's about her. I'm glad she's not here. So GitHub is a team sport. So I'm Matt, I work at the strategy unit. You heard from Rian earlier, who I'm going to punk in a minute. And we've got a few more of us down the front here as well. The sort of too long didn't read of this. If you want to fall asleep, you're very welcome. GitHub is a place where you can organize code, conversion control code there. But actually GitHub can organize people, yes. And I want to tell you a little bit about that and how we at the strategy unit and the data science team are learning as we go. So a little bit more context. I mentioned the team there. This is us, or most of us. We're expanding. It's slightly grandiose to say that we're like the Power Rangers. We style ourselves as such, with Chris as Zordon, if you're a fan of Power Rangers. So these represent some missing staff who are arriving very soon. We are all remote. We've all got different backgrounds, different skill sets, R users, Python users, etc. Even a Haskell user, Tom. And something we do more often than not is work on the new hospital program, which is extremely complex. There's lots of tasks, there's lots of stakeholders, there's so much going on, it's quite hard to keep track of. The question then is, how can we, with our different backgrounds and being in different locations, and having such a complex task or set of tasks to do, how can we keep on top of all this? How can we work together? So, ancient meme, but the dream is very much to get out of this situation, try and get some order from the chaos that exists. Part of that comes down to just good communication, right? Talking to each other, having little calls and things, seeing each other in person and realizing that I'm much shorter than everyone thinks I am. But also something that we really want is to minimize something called the bus factor, which is, if one of us gets hit by a bus or other form of transport, that all that information is stored outside that person's brain that's now splattered on the concrete. So we are living the dream, I would argue. What we're doing right now works for us. But we've got new folks joining, and tasks are changing all the time. Stakeholders want the button to be blue, as we heard earlier. That's pretty common. And we're sort of, I think, accepting that things will change, and we're open to change. As we get new staff, like they'll have new skills, they'll have new desires. They might know a thing that we don't, and we're very happy to accept that. So on to some features of GitHub. This was originally part of a longer talk that you can find on our data science website, but I've taken a few little tidbits from there that I'll walk through. They go from quite broad to kind of quite narrow. Hopefully there's something in there that you'll find useful. I should say as well, the drinking game is that every time you see Rian's face, you're supposed to take a drink. There was one already, so thank you. So the first thing is GitHub projects. This is I feel like it's kind of relatively new and it's advancing all the time. With all of these different issues we have across lots of different repos for the new hospital program, we are using this ability to kind of set up kind of Kanban boards and the ability to kind of arrange issues from multiple repositories kind of in one place, so we can see them all at once. We can rank them against each other and see like what needs to be done first. We can see what's in a backlog, et cetera, et cetera. And we also want to be able to show progress to people who are outside the team. What are we working on right now? What's coming next, et cetera. On the right-hand side here is just a little screenshot from inside an issue that's part of this wider project, which allows us, as you can see, to add like additional labels in. So we have things like, well, when's it coming? When's it due? What's the priority? And obviously there's egregious use of memes in the form of emojis here. And size at the bottom there is t-shirt sizing, which I've only recently learned is a way of being able to sort of guesstimate like how big a task should be. But we did have sort of an unfortunate moment where one of the shirts would need to be extra large. So maybe that doesn't quite work. So something to learn there. What does that actually look like in practice? I mean, I've grayed out all of the kind of names of the tasks and things here. That makes it seem really mysterious, and that's the only reason I've done it. But basically, here's a screenshot of what it looks like in a GitHub project. Again, we've got kind of backlog, in progress, in review, this kind of thing. And we've also got the ability to nest issues, and so we can break out and explode things. There's calendar views, there's all these kinds of things. How many times does Rian's face appear on here? One, only two. 2 shots, please. Thank you. The next thing I wanted to talk about was this idea of kind of division of labor in what we do. Oh, there she is again, drink. So we have this idea of having a Scrum Master. Chris will talk later about how we're using Agile development. But we have like recognized people doing recognized things. There's always a point of contact. So our Scrum Master is in charge of kind of putting things into our backlog, making sure that they're passing through the process for the end of our sprints. We also, within repos themselves, have owners and deputies who are named people, and you can put those in a special little text file called a code owners file. And that's important because then there's someone in charge of being able to clean up the repo and make sure it's tidy, make sure that there's no stale pull requests or branches or anything like that. And then finally, down a level again, issues and pull requests, I think we're pretty good at making sure that we label who is putting the pull request forward, who has picked up the issue to be worked on. And that's a way of being able to communicate who's working on something without having to constantly be messaging to say, oh, have you done this? And to make sure that we're not kind of doubling up. I've just noticed Rian at the back of the room. Hi, Rian. Yes, thank you. The next one, which is kind of related to labeling as well, is task sorting. So we use mostly the Moscow method, which MSCW is must, should, could, won't. It's got nothing to do with Russia. And that really helps us for things like being able to efficiently triage and be able to pop these things into milestones, which is another feature of GitHub that allows you to organize. And that's really great because we can say, version 3, we need these 3 issues done, and then we can release. So that's a really nice way of organizing. And then finally, right down to the level of pull requests themselves, having just said there's lots of different methods for kind of labeling things and not having to talk to each other, turns out you do have to talk to each other. Rian's face. Drink. So suggestions is something we found really useful, and here is an example. I am spelling things wrong all the time, so here I'm insisting that the word mitigator is actually mitigatore, if I'm pronouncing that correctly. And so what happens here is that Rian is able to say, it's pretty simple correction. I'm not going to suggest that you go away, go back into your branch, make the change, and then push it back up again. She, within GitHub, can make this suggestion. There's a little box that has like a plus on it. And then I see this in the review as like this kind of nice diff, and I can just click on commit suggestion, and then we get like joint ownership of that commit, and it's all done in line, much quicker, much faster. Surprise twist. Turns out that we're not all human on the team. GitHub itself is a team member. And so that's through things like automating with GitHub Actions, so being able to write little recipes, little scripts, that when there's a push or whatever, basically, if there's some kind of action within GitHub, we can then force something else to happen. So in this case, this was like a push was made to the repository, and GitHub Action was run to be able to build a website, in this case, and deploy it with GitHub Pages. And then we've heard a little bit about things like issue templates and repo templates. We're using the issue templates a lot more, and they're really helpful for working kind of across and beyond the data science team as well. So we can kind of force people to agree that they've read the README before they start making issues, for example. So what's the underlying message? Yes, GitHub has lots of kind of handy kind of affordances and features that might be useful. Maybe you've heard of some, maybe you haven't. Maybe you want to try some out. Maybe you want to tell us some more about what you might be doing that might be useful. But crucially, what is the sport? The sport is curling. We are curling. We're a small team. We assume specialist roles, and we work in sync. And this screenshot is just to show that GitHub can be a silly place. That is allowed. So Rian, oh, it's not her face this time. You can't drink. You're still pushing curling then. As analogies go, I think that's nice. I don't like to make sweeping statements, but stone me, all your puns are terrible and there's no room for them here. Right, so Chris then did come back with even better puns, but I had to truncate it because it wouldn't fit on the screen, so I get the last laugh there. But actually, what is the bottom line? So this GIF is me being hit by a bunch of tasks, and that's my teammates. I was going to say picking me up, but they seem to be holding him down actually now that I look at it. So maybe that's more apt. So what I'm saying is, GitHub can be really helpful, or GitLab, or whatever other tools you might use. But actually that still doesn't kind of replace the ability to communicate with each other, help each other, and just be kind. Thank you very much.
So we don't have any questions yet, but I can see people are typing. So, oh, here we go. Any tips on how we play nice in GitHub?
So tone is a problem, right? Like when you're typing stuff, it's hard to know. So first of all, it's just being aware of your tone, I think, to some degree. Also, yes, the use of emojis, I think, is quite helpful. Actually, seems silly, but like, little wink, little tongue out, that kind of thing can go a long way. But as I was saying here, actually, it's not just about the written stuff. Still, you do have to kind of talk things through sometimes, a little message here or there. I think it also helps, and we do this a little bit, if you are putting a pull request in, for example, it's something you feel a bit unsure about, like communicating that in the body of the pull request itself, saying, actually, I've done my best here, I'm not sure if it's quite right, can we talk it through? Can you give advice on this specific thing? I think that really helps, and that's something I try to do wherever I can.
Makes sense. Do you use any specific guide or document on how to review code and comments to a pull request with some standards within the team?
I don't think we've got anything written down necessarily, but that is something that we have been trying to do a little bit more, kind of recording these processes. So we have a data science website I mentioned, and on there we've got kind of a guide for doing certain things within GitHub, and there's a little bit on like pull requests and things like the code owners and all this sort of stuff. We don't, I don't think, want to, I'm looking at the team, I don't think we necessarily want to like hard code, like write down in stone, like you must do it this way, because we need a bit of flexibility around what we do. Sometimes, I'm not saying we YOLO merge at all, but sometimes you need to do things quicker, and like you've got to respect that you can't do quite the same kind of intensity of a review, for example, compared to something that's huge and more important. But then we're also advising on things like keep the pull requests small, like fix one issue, like that kind of thing that can help with that, that we also have written down. So it's kind of a mixture of things, a little smorgasbord of bits and bobs, yeah.
And another question, so around change of culture. How can you implement the collaborative features of Git in a culture of isolated and siloed analysts?
Yeah, bingo. So I spent probably a decade or so mostly working by myself in GitHub. And you can start to practice these sorts of things, by yourself, but it's a lonely existence. One thing that we're looking to doing a bit more is having people who are not GitHub users, not coders, being able to arrive at the repository that you've created to supply their own issues and start to work on maybe some smaller things like adding some detail to README files and this kind of thing. So you might be the lone coder, but you don't have to be the lone GitHub user necessarily. That's not that easy. You need people who are interested, but you can shortcut that by saying things like, okay, well, either we can go back and forth for 50 emails to bash this thing out, or we can bring it to where the code actually is in place and do it that way. So yeah, that is that is tricky. I'd love to hear more from people as well who are working in kind of isolated environments and how they're handling that. But yeah, as I say, we're also growing as well. We've started off relatively small, getting more and more people, and so there is this kind of effect of the opposite problem in some ways, like having to deal with a larger set of people rather than few. Not sure I answered the question, but I talked for long enough to make it seem like I did.
I think that counts. Does that still work? Yeah, it is. So last question, so if I can get back to lunch. Does agile ways of working work within your team?
Well, if you hang around for Chris's talk later, then you'll find out.
I think that's a good note to wrap it up on.
Thank you.
Cheers, everyone. Time for lunch. I look like I'm about to say something else. I'm not. I'm just putting the microphone back. So.